Alright, so I'm going to show you how to create the correlation function on your calculator. In order to test it, we're going to need some data. So on your calculator, when we do this, you'll have the Old Faithful data set, but it's kind of a pain entering data into the simulator. So I've just created some fake data. I've got it stored in L1 and L2. And if we go to stat plots, and I already have the scatter plot on, but just to show you, turning on the scatter plot, and then graphing. This is what our data set looks like. So this is a relatively strong correlation. Everything is approximately linear and it's positive. So what we want to do is create a function that actually calculates the correlation for us. So it quantifies numerically how strong and in what direction this relationship is. So the result we would expect should be a number close to 1 that's positive. So what we're going to do is we're going to go into program, and this is where we can create new functions for our calculator. I've got 2 already created. This is a project we're eventually going to do in class. We'll talk about that when the time comes. So what we want to do is create a new one. So we're going to go over to new, and we're going to create new, and that will bring up a program editor. And the first step here is you got to name it. So it'll put you into alpha mode, and you just got to type in the name of the function. I want you guys to call it Coral. There is a character limit. We mentioned that in class. It only goes up to, I think, 7 characters. So I'm just going to call it that. Then hit enter, and it brings up the program editor. So this is like a text editor where you can enter commands on your calculator and store them into like a repeatable procedure. So notice the colon. That represents a new line. So my cursor is blinking on a new line. I can create a new line by hitting second and then going to insert, enter, and I can create as many lines as I want. Then use the arrow keys to choose which line I'm editing. So what I want to do is, I guess, tell the user what the program's doing. So we're going to print the screen the name of the program. So that is a function that we haven't seen yet, but you can print text to screen. And the way you do that is when you're in the program editor and you hit program again, it brings up a special menu. And these are commands that you can add to your script. So this first menu here, control, that's what the CTL stands for. They're control structures. So some of these might look a little bit familiar just from what we know about Python. All programming languages are basically the same. They all do the same thing. They just have slightly different syntax. So once you know one programming language, it's not very hard to pick up another one. And the one on your TI calculator is very basic. It's actually called TI Basic. So it's pretty intuitive. Let's go over to the IO, which stands for input output. So these are functions that allow you to either get data from the user or display data to the user. And what we want to do is use the display function, which is sort of like print in Python. It'll print text to screen. So we're going to put that function in our program here, and then we're going to pass in a string. And the way you do that is with quotes. So quote is the alpha and then the plus. And then just write correlation. Correlation. And then end quote. And then what I'm going to do is, there it is. I'm going to put a line to separate the output just because I want it to look nice. So I'm going to put a bunch of dashes. And let's make it equal to the amount of letters in correlation. Alright, so let's back out and see what we've done here. So now we're on the main menu. If we go back to program, it'll bring up the regular program menu, and now we have a new function. So this first menu is called the execute menu because it'll execute the function we just made. So if you select the function and then hit enter again, it's going to execute it. And notice it prints what we just put in there to screen. So we have a stored procedure on our calculator now. So now we actually want to calculate the correlation. So let's actually look at the data. So remember the formula for correlation is we want to standardize each list. We want to calculate the z-score of each list and then multiply them together and take the average. So what we want to do is program those commands, the commands that we've been using in class in order to calculate it manually, but now we want to make our calculator do it automatically. So we're going to back out and go back to the program menu. Now, since we have a program already created, we can go to the edit menu and it'll bring back up the saved program. All right, so this function we're creating is going to assume we have the x variable in L1, so the independent or the predictor variable in L1, and it's going to assume that the response or the y variable is in L2. Now, it's important that you keep this in mind because the function will not work if this is not the case. Eventually we might do this. We might introduce some control structures to validate input so that this function will work for a wider variety of cases. But for now, the function is just going to assume that x is in L1 and y is in L2. If that is not the case, then this function is going to error out and you'll get that error printout on your calculator that says error. So what we want to do is create a list that standardizes the x variable and a list that standardizes the y variable. So let's do that. We're going to standardize L1. So we're going to say L1, actually parentheses L1. And we're going to subtract the mean of L1. Remember how we do that? We just go to the list menu over to math and then select mean. We'll take the mean of L1 and then remember we divide by the standard deviation. So we're going to go over to math and calculate the standard deviation of L1. All right, so that'll standardize L1, but then we have to store it. So we're going to store it into one of the empty lists. Let's say L3. All right, so that standardizes the x variable. And just to illustrate, if we go back to the main menu and re-execute the program, notice it actually gives you a little printout. I didn't expect that. But if we now go into the stat editor, we now have a new list. So this is the x variable standardized. Now let's do that for the y. So go back to program and then edit correlation. And then start a new line and do the same thing but for L2. So subtract the mean. 3 L2, then close your parentheses and divide by the standard deviation. 7 L2, and then we want to store that into a new list. So let's store it in L4, let's say. All right, so now we've standardized x and y. We want to then multiply the z-scores and store that in a new list. So let's do that. Let's say L3 times L4, store that in, let's say, L5. Okay, one more piece of information we need, and then we can actually calculate the correlation. So we need the total number of observations. Now, we know in this case it's 6, but we want to do it in general. So remember the way we do that in general is with the dim. It's going to give us the dimension of the list. So in this case, it doesn't matter which list we use because they should all be the same length. So we'll just take the last one we made and we'll store that in a variable. We'll call it n. Okay, getting closer. So now we want to remember the formula. So it's the sum of the product of z-scores. The product of z-scores, well, we have that stored in L5. So what we want to do is calculate the sum of that. So again, we'll hit second list and we'll go over to math to get sum. We'll say the sum of L5 and we want to divide that by, remember the formula, n minus 1, n minus 1. And then we want to store this calculation, store, in what's called R because that's what we're using for correlation. All right, final step. we now want to hit program because we want to display that output back to the user. So we're going to say display R. Okay, that's it. Let's back out, let's clear, and let's execute our new program. Oop, error syntax. Let's go to it and see what we did wrong. Oh, I got too many parentheses. Okay, so let's delete that. Second quit and try it again. There we go. Okay, so let's verify that this is indeed correct. So make sure your calculator is in stat diagnostic mode, which is mine is. So we're going to go to stat, calculate, linreg, pass in everything, calculate, and there you go. So the correlation is 0.7888, and our new program will give it to us. So it's a way of calculating the correlation without making sure your calculator's in stat diagnostic mode and without running linreg. So this is kind of nice. It's a nice little function that we can use instead of calculating correlation by hand or going through a bunch of hoops to get it. So this is the first part of the project, creating this function. The next part, you're going to be creating another function called SSE. So let's actually just create the stub real quick. SSE. So for this one, there's a step you need to perform, which I'm just going to give to you right now, so hopefully everybody watches this. You have to run the linear regression program. So remember, SSE, that is the sum squared of the error of the regression model. So it's the sum of the residuals squared. In order to get the residuals, you need to find the line of best fit. In order to get the line of best fit, we have to run the linreg program. So you can do that in the program. Let me just back out real quick. Edit, SSE. So go to a new line, hit stat, and then go over to calculate and linreg. Now, when you're doing this programmatically in a program you created on your calculator, you have to manually tell it what lists the data is stored in and where to store the line of best fit. So we're going to say L1, comma, L2, and that's telling it this is the X and this is the Y. And then you have to tell it to store it in one of our function variables. So we want to hit alpha, bring up this menu here, and say Y1. Okay. So this is an important step in this program because you need to actually get the line of best fit in Y1. So just to illustrate what we've done, if we now run this program, okay, so notice it ran the linreg program for us and it output the line of best fit. And if we hit Y1, notice we now have that function stored in Y1. So what you want to do in this program here is think about what you have to do after you get the line of best fit in order to calculate SSE. So in other words, you need to calculate the residuals and store them in a list, and then square the residuals and store that in a list. So I'll let you think about it. You can always email me or post on Google Classroom or whatever. But that's the project. That's what you need to do. Let me know if you have questions.